Hi, good afternoon. This is John Bloom, and today I'd like to talk about neural nets in AzureML. Now, I did this video earlier, and I just felt like I kind of missed some of the important points, so I'd like to go ahead and redo it. So that's what this video is here. So what is neural nets? Well, neural nets is a structure that resides, in this case, in Azure machine learning. And what does it do? Well, neural networks can be used for learning behavior and patterns. And the way that it works is that the neural network receives input parameters from a variety of sources, such as text, pictures, data, speech, sight, images, and it can process those images and look for patterns, and it basically teaches itself over time. So as the network receives those input parameters, what happens is they go into these synapses, these neurons, and the neurons are kind of mimicking the human brain in the fact that it's a structure of neurons, and each neuron has an algorithm, and it does a calculation, and depending on the output of that calculation, if it's close or equal to 1, what it does, it fires downstream to the next connected neuron. And there could be multiple layers of these neurons that get fired or not fired, and it can trigger events downstream. And the synapses that connect them, they route the information accordingly. And then it goes into this hidden layer. And this hidden layer is another series of algorithms. And that's where a lot of the actual calculations and the intelligence is built is in these hidden layers. And then finally, the output is generated, and that's what is the result. So one of the methods that was developed a while back is called backpropagation. So what happens is you send through a series of data, test data, to train the model, and after you test the results against the actual data. And if it doesn't match, you run this process called backpropagation, which backfills the network so that it trains it backwards, so that it remembers better. So it's better determinant of future outcomes that are more accurate. So with the Azure platform, we have the preview portal, and from here, you can click on the plus. And from the plus, you can click on Data and Analytics. And from there, you click on Machine Learning. Now, when I click on this, it's going to take you to the other portal, the Windows Azure portal. There's actually two portals. One's a preview, and this is the live one. So you'll see that once it renders, we'll go ahead to our Machine Learning workspace that's already been created. And once we click on that workspace, you'll see that we already have a sample project that I already created. Now that sample project is one of many. There's like 3 or 4 pages of samples to choose from, but in this case I purposely chose the neural network. And so that project's already out there in my workspace, and once it renders here, we'll be in good shape. So we'll go ahead and click on the platform. So neural networks have been around for a while. The problem was that they couldn't handle the data, and you run jobs and they would just crap out after a couple of days. So they didn't have the processing power. Now we do. And we also have the technology in the hands of developers like myself, where previously it was restricted to graduate PhD students in university structure. So this particular project, you can see the experiment demonstrates the usage of multi-class neural network model to train neural network, which is defined in NetChart. So what is NetChart? Well, that's this new language that we have to learn. And if you wanted to see an example of it, I would click here and here. So what you're seeing is 3 lines, which is 3 layers. The first layer is the input, the second layer is the hidden, the third layer is the output. We declare this variable called picture. which gets passed in, and that's the hook into the second layer. And then this H variable is the hook into the third layer, and that's the output. And you can customize this. You can have single or multiple parameters. And there's all sorts of weights. Now, one thing I didn't mention is that each neuron has a calculated weight, and you can adjust those, and that'll determine better or worse accuracy depending on how you tune it. So in this case, we have a sample data set from this MNIST, and that's just a generic data set that's out there. This data set has 60,000 rows, and this one has 10,000. So this 60,000 is going to train the model along with the neural network class, multi-class, and then this 10,000 batch is going to go straight to the scorecard, and the train is going to go to the scorecard, and that'll get evaluated. So we train the model, we score the model, and then we evaluate the model. And the evaluation, it compares the actual results, which is probably this 10,000, against the test, which is the 60,000, to verify the accuracy. And finally, we have some R code here, Revolution Analytics R, and it receives an input, it does some calculations, and then it checks for accuracy, and then it produces an output. I'm going to go ahead and run it. I can't remember how long it takes to run. We'll find out here shortly. Hopefully it doesn't take 20 minutes. But if you're familiar with the Microsoft world, this looks like SSIS, Integration Services, and the fact that there's these components that you drag and drop, and they're all linked together and stuff. It's similar to it, but it's different, and it's obviously web-based, which is nice, and cloud-based. And the entire Azure platform is pretty much cloud-based, and that's definitely a selling point right there. So it looks like it's finished, and it ran. Yeah, it's finished. So if we were to look at some of the output, perhaps, this one here with the visualize, it has a bunch of information with your input, your hidden layer, and your output. So that's good. If we jump on down to here, perhaps, and visualize this one, you'll see it has a graphical image. I'm not exactly sure how to interpret it, but I do know that 0.97 is close to 1.0, which is 100% accuracy. So it looks like the test data is right on to the live data matches the training data, the sample data. So that's good. And then finally, if we look at this, see what we get. Yeah, it's the 0.977%, just like my GPA in high school. Yeah. So I would have done better in high school if the people next to me would have studied a little harder. So that's all I got to say about that. So anyway, so that's basically a neural network machine learning experiment within the Microsoft AzureML platform. There's another thing I wanted to mention called the sweep parameters, and basically it's used because these neural networks can be trained differently depending on the parameters and how you tune it. So the sweep parameter allows you to, in one sweep, pass in multiple parameters. It determines which is the most accurate, so it saves you time. And this is a good link here for getting up to speed on this net sharp language, and it goes into granular detail. I still need to read through it. A second read to get more familiar with it. So that's that. And basically just some links here based on that to get you introduced to, and those will be included in the blog post that we'll see shortly. So I'd also recommend this language here, this web page, because it goes into detail about this these parameters. Like for example, 28 times 28 happens to be 784, so I guess you could do either one. And that code that we saw earlier in the project is exactly right here. So that's some good information. So I've been studying neural networks for a couple of years now, and this is great that we have a platform to just log on and start playing and learning at your own speed. So if you're in the data space, this is good information, as neural networks is only going to increase in popularity. So once again, thanks for watching, and stay tuned for more videos in the future.